And welcome to the bi-monthly Industry 4.0 community podcast hosted by 4.0 Solutions. I am your moderator today, Walker D. Reynolds. Today we've got Sean Robinson from Novatech, who's joining us from a conversation we had on LinkedIn. And we're going to be talking about building versus buying MES. This is obviously something we've been talking about a lot over the last 4 to 6 weeks because we did the core MES bootcamp last year. We did we're about to do the advanced MES bootcamp. And we've been talking a lot about, obviously my position is that everyone at some point eventually builds their MES, whether they're building 10% of it, 20% of it, or 100% of it, you eventually build. Sean has a long history, long background with manufacturing execution, solutions development, you name it. And he has so graciously joined the podcast to have this conversation with us. And we're going to bring him in here in a couple of minutes right after we do our announcements. So for those of you who are in mentorship, we have our mentorship call this Friday, 9 o'clock. The sprint number 2 for Virtual Factory has been extended to Thursday night. I'll be reaching out to a couple of the developers. So Amy Williams, Dylan, a couple of you who have been doing a lot of the development of Virtual Factory. I'll be reaching out to you guys tomorrow to touch base on some of the things that you guys have developed. Second ChatGPT workshop, Wednesday, April 26th. That's next Wednesday at 10 o'clock in the morning. Remember, we're going to be building 2 products from scratch. One of them is going to be a spark plug product. Obviously, the first workshop was a huge success. I'm really excited. We got 4 hours, which means we're probably going to do about a month's worth of development, like a 4-hour window, which is awesome. First advanced MES bootcamp session is next Saturday. So after the ChatGPT workshop at 8:30 in the morning, that's what we're going to be doing. We're going to basically be migrating core to our advanced architecture. So all the visualizations will come through the unified namespace. We'll build a couple of custom features, specifically defect tracking. And I think we're going to do changeover. And then we're going to move all of the code to an external Python library. For those of you who are in the Northeastern United States, remember, I'll be speaking at MES MEP on May 19th. I'm doing the keynote address first thing in the morning, I think 8 o'clock. That's May 19th is a Friday. So if you guys want to go, the link will be in the description of this video. If you guys want to come and see that. And then I'm also going to be speaking at IoT Happy Hour here in Dallas on June 1st. And with that, we'll bring in Vaughn, Zach, and Sean. Ahoy, everybody. How's it going?
What up?
Awesome.
So Sean, here speaking at all these events.
Sean, thank you for joining us, man. So real quick, so we can get right into the MES conversation, because I'm actually going to read through the thread, our back and forth, so that everybody who's listening knows what the exchange was. Why don't you go ahead and quickly introduce yourself? Who are you? How did you get to this exact moment?
Yeah. So I think probably the highlights worth mentioning. Fell into industrial IT by accident back in 1993. Up to that point, I had done what all good Canadians do, which isn't being a lumberjack. It's actually joining your mom and dad in a family business and graduating from dealing with just IT infrastructure during the first PC and client server revolution to hanging up a shingle that says we'll do database back systems development for hire. So everything from season ticket management systems for sports franchises to actuarial systems to display advertising and magazine circulation management. So when the steel mill said, could you write us a scheduling system? We didn't know that was hard. So we said yes.
Okay.
But we were clever enough to realize that once we'd written a schedule, that a schedule that has no feedback is kind of useless. So we wrote them a data collection module, some basic quality management, some labeling, and a few other things, and said, look, we thought these would be useful. And they said, geez, you're right. What should we pay you for it? And the next thing you knew, I'd accidentally become an MES guy. And over the years, we refined a few things. So we zoomed particularly in on finite scheduling. Hot tip, if you don't get on that well with your family, don't stay in business. So you should eventually license your technology off so everyone can retire, or at least, get on to the next stage of their life. So we did that. Got the heck out of high tech for a few years, which was great. Worked for, proper distribution company with a little light manufacturing. And it was great watching tangible product leave the dock every day. And then a chap rang me up one day from an SI firm and said, I understand you know about finite scheduling and MES. And I said, who told you that? Your dad. Well, I guess I can't deny it then. So I came and joined an SI for a few years, hopped to a different one, was stolen by one of the global IT vendors, had an interesting purview there, particularly focused on food and bev and CPG for a few years, and then decided I'd join Novotech, who's a partner to said giant global company, because the beer's better in England. And
so
that's basically the highlights. I'll leave it there, but if anybody asks why I've got certain opinions, they now know the whole gory thread that got me there.
So two quick questions. So number one, in steel, was this rolling sheet? What was the steel?
So this was the steel rod into wire fence and nails. That was project number one. And in fact, that was where we probably really cut our teeth as a group on the concept of an abstracted data model that could be used to describe diverse manufacturing operations from within a single system.
And then for those who don't know finite scheduling, I'll go ahead and let you explain finite scheduling.
Oh, yeah. So bearing in mind, we're going back to the ancient 90s, right? So this was when most people thought MRP was exciting. So the finite scheduling job was to actually take physical constraints at the individual asset or process level, marry those up to physical product characteristics, and then find ways to optimize the sequence in terms of the way production would be released to the floor. So you could do things like minimize changeovers, minimize quality risks, because you don't want to make massive changes from, say, one die set to a radically different die set when you're drawing wire to different thicknesses. So the finite part was very much about taking a broad demand plan and turning it into very specific sequences of orders to run in different work centers.
Okay, excellent. And for the layperson, what we do is we talk about this in terms of in scheduling and manufacturing. You want to produce as much as you can in the same amount of time every single day. Every manufacturer generally has a finite amount of time to produce in a given day, and it is not 24 hours per day, believe it or not, because no manufacturer runs 24 hours a day. Even if they're on a 24/7 schedule, they still have some type of scheduled downtime so that they can maintain their operations. So if what I want to do is I want to optimize what I produce in the same amount of time every day, the order in which I produce things oftentimes matters. Going from product 1,000 widgets of product A to 1,000 widgets of product B to 1,000 widgets of product C is not the same as going A to C to B if all the little elements of changing between A to C is easier and C to B is easier. You want your sequence to be A to C to B. So we talk about this, we want to optimize our scheduling plan so that we're reducing the amount of time it takes us to prep for the next type of product that we're producing. Okay. Yeah. Awesome. Well, so let's talk a little bit. Your background, you have a background in GE Intelligent Platform, right? You were with GE there. Novotech is and for those of you guys who don't know the whole GE background, you had GE Digital, GE Intelligent Platform. I think Emerson bought GE Intelligent Platform. They didn't buy Digital, right?
No, they bought the automation hardware platforms and the related business. And of course, that particular divestiture caused all sorts of brand confusion for a while.
Right. And so Emerson's got a piece. Emerson bought a big chunk of GE's Intelligent Platform business, which included a bunch of verticals and sectors. Yeah.
PLCs and hardware and all that stuff in particular. So if you're familiar with everything from a Series 6 to a Series 90 to an RX3i, that's what Emerson bought. If you're a long-standing user of GE software products like their Historian, their Plant Apps MES, their iFix, their Simplicity SCADAs, GE Digital retained those.
Right. GE Digital still has Prophecy and all that stuff. But originally, Prophecy was under GE Intelligent Platform, but GE Intelligent Platform has been dissolved, and now it's just GE Digital, of which the software platforms fall under. Novotech is a Emerson distributor, right?
We're that and a GE Digital partner.
GE Digital partner, Emerson distributor. And then, but I want to point out one quick thing. You guys also are, you guys do PTC Kepware, and you also do Avessi's Virgin Dog, which, by the way, a little intersection here. I did the keynote address at MDT Avessi's thing last year. I think it was last year, right? Yeah. So I'm by the way, huge fan of Version Dog. A lot of people here in the States haven't heard of Version Dog. So in Europe, everybody knows about it. In the United States, they don't. Huge fan of the Version Dog software. All right, with that, let's go ahead and get into how we had this original conversation. So we did a post on LinkedIn. I think Josh, I actually wasn't part of this post. So, but our digital media team posted where people get MES wrong. And it was, if you work in manufacturing, you've probably heard of MES, or Manufacturing Execution System. However, many people misunderstand what MES really is. It's not a product that you can simply purchase off the shelf, but it's rather a quilt of capabilities that must be put together to fit your unique needs. At its core, MES is the place where a sales order is transformed into the execution of manufacturing. One of the biggest mistakes that companies make is assuming that an off-the-shelf MES system will work for their business. Unfortunately, these systems are designed to enforce the model that exists in the ERP, which doesn't account for unique capabilities or edge cases specific to your business. Instead, your MES system should be a reflection of the reality on the plant floor, designed to be flexible and customized to your specific needs. In fact, no one on the plant floor has ever said that they can't do something just because the ERP or MES system doesn't allow it. Production is always king, and people have and will do things to make sure production happens, whether it's manually moving parts or setting up a temporary conveyor. Your manufacturing execution system should be built to accommodate and support your production needs, not impose a rigid structure from the ERP. So everything that's in there, I agree with. I would have changed the words a little bit. I would have put a couple of qualifiers in the middle, but everything in there, 100%, I agree with. Okay. Sean said, I honestly can't tell if this post is intended to undermine MES concepts and packages through non sequiturs and misdirection. For those who don't know what a non sequitur is, it's when you draw a logical conclusion where a logical conclusion does not exist, and misdirection, or if it's simply based on a fundamental misunderstanding of why the MES space grew in the first place. The whole point of MES's existence is precisely to separate, among other things, dispatch, finite scheduling, activity management, WIP execution, and quality operations from the cost center focused financial systems layer. And to the point that Sam Kirby makes, who he had a comment earlier in the thread. There are solutions that are highly adaptable to different process and production models, as well as to different levels of automation versus human-driven work processes. There are many one-trick packages that have been bent out of shape by their vendors in an attempt to create a broader capability off the back of an originally limited data model and function set. So it's entirely possible to witness a series of failures based on poor fit and/or execution. But to make these kinds of sweeping statements betrays either a lack of familiarity with any of the many real good MES solutions available, or possibly a desire to create confusion and therefore space to promote an alternative toolkit and approach to delivering the underlying requirements. So I'll pause there because I come in after this. Yeah. What I would say is when I first read this, I said, I think there's a miscommunication.
Possibly, or I'm just not very much of a diplomat. I have been accused of being a little bit of a, you know what on occasion.
And by the way, you're in very good company. You're in very good company because I am accused of those same things. What I will say is we don't have a toolkit. We don't have a solution. We have a philosophy. And so that's what I follow up with here. So my comment here is, I'll put it this way. There are exactly 0 off-the-shelf MES solutions that can be fully integrated to a complete organization without requiring the business to change in some way to fit into the solution. If you install a SCADA solution, what changes? 0. It's data acquisition, supervision, and control of what is there. Now, that's not entirely true. You have to train operators to use it, and what the operator does changes because they're now around a control panel as opposed to walking the plant floor. But in terms of the function of manufacturing, it doesn't change. MES is, in fact, an abstraction of operating events, some coalesced into transactions, some transformed into KPIs, but all referenced against a digital model of operations. There are no non sequiturs here. The conclusion that all MES are, in fact, built, whether as extensions of off-the-shelf platforms or custom-developed back-end API UI via the software development lifecycle, is derived directly from the fact that there exist exactly 0 implementations of off-the-shelf MES with full organization integration. So full stack edge to cloud, wall to wall, without requiring the organization to change their operations to fit the solution in some way, or without leaving behind data and edge cases the off-the-shelf solution cannot account for. What we showed here was less than $40,000 total cost of ownership in about 12 weeks. Today, 3 years later, total spend is less than $1 million for the entire organization, and they have 100% functional coverage zero operational changes. And so I think one of the things that we didn't do a good job of in the beginning post was everything is a function of time and money. One of the things that we put a premium on is making digital transformation accessible to everyone. Yeah. So, and you do that by making the cost as little as humanly possible and the time to value as short as humanly possible, which I don't think we did a good job of explaining. And I want to follow up on there was a survey we did, I want to say 4 years ago, which was we wanted to ascertain the 5 biggest challenges organizations face when implementing MES. And we distilled them down to these 5. So if I'm an organization and I want to do a manufacturing execution system, and Sean, I want to get your opinion here. Yeah. These are the 5, what we've distilled as the 5 greatest challenges you're going to face. So number 1 is data integration. So MES solutions need to interact with various systems such as ERP, yep, PLM, and other manufacturing software. Ensuring seamless data exchange between these systems can be complex and time-consuming, especially if they use different data formats, communication protocols, or from different vendors. Right? We agree. That's a huge challenge. Right?
It can be. I guess that's one where it comes down to organization. I suspect where we're going to agree the most is if you've not built your organization as an end user correctly, so that traditional armed camps of IT over here and OT there, and people doing stuff for ops, but ops feeling like it's being done to them.
Right.
I think in the healthiest organizations I've seen, they'd actually argue that data integration is less of a challenge once the humans learn to talk to each other, because it's all very easy to translate. And, you know, there's been great examples over the years where, you know, people look at everything from regulatory pressure to, you know, some of the schemes that you use for e-commerce with trading partners, and how quickly and easily you can sort of use examples of things people have solved and say, well, if you can exchange this data as the provider of milk to, I'm going to try and avoid manufacturer names, a company that makes chocolate, why is it so difficult for you to take a subset of that data and move it from this silo here into that silo there?
Who writes the standard for the way that you format it?
So interestingly enough, and again, this is a bit of a non sequitur, but thinking of that integration, take a look at the EDI X25 standards for e-commerce. And the funny thing is, if you take a long, hard look, they map really closely to what B2MML looks like for us MES nerds when we think about first generation message-based exchange. And the minute you've got somebody from call it the customer service side of IT and somebody from the MES side of IT realizing that these are 2 different, you know, standards for structuring a message that are essentially identical in purpose and only different in labeling, suddenly a whole bunch of those other questions about data integration get a lot easier to have, because you've just, with that one example, you've demystified what they used to, you've demystified something they can both understand in terms they can now both understand. And that means they're a lot more likely to be able to say, okay, well then what's different about, you know, exchanging a quality record from a, you know, standalone CMMS type system with an MES? What's different about getting underlying process parametric data into a format that an MES can actually look at it and say, I'll let the machine tell me whether or not my process is stable. I don't need a human to do it.
Well, the problem is, the challenge that most people face is that, and I would argue in the OT side, the biggest challenge on the OT side is that, you know, it's this old adage. You give the same functional specification or sequence of operations to 10 different PLC programmers, and you're going to get 10 completely different programs that do exactly the same thing. But the underlying parametric data that you talk about is a function of how they did it, not what they did. Right. So the format that it's in, the tag naming, the which register I used in which register table is a function of what that programmer does. And oftentimes, you know, we used to make this joke in controls, and you were a system integrator for a while, so you're familiar with this. You know, controls is the last group brought in, and whenever they're brought in, you're already 2 months behind schedule, and they wanted everything done 2 weeks ago.
Yep. So depending on the skill sets in the company, they may not be people that think about data abstraction, and therefore it can be a real SOB to get them thinking about, you know, structure and schema standards, because to them it's the machine. To the supply chain guy, it's, is it predictable? To the materials guy, it's, did the supplier material perform? And, you know, just to give people on the call a little anecdote here, just to put, you know, this is one of these areas we violently agree, Walker. And I'm going to not name names again, but a few years back, an automotive company was looking at deploying what I consider to be a weak model OEE solution into their stamping press area. It was a big plant, you know, so it was not a small job, but we went away, we did our homework, we took a look at it and said, okay, you know, to actually deploy the OEE parts and reporting and the like, you know, using the tool that you like, it's about $250,000. The kicker is that you're going to spend $2 million doing PLC remediation.
And explain a light OEE. Explain to us what a light OEE model, like what that means.
So when I say a weak OEE model, I guess what I mean is that it was a platform that really only understood, call it first layer events, right? So one type of broad categories for downtime and waste. It didn't really give you a way of establishing secondary causes, and it certainly didn't give you a way of saying, look, if there might be smoking guns in the parametrics, like if my cycle time on my stamping press is a little off, maybe I'd like to look at things like oil pressure. Maybe I'd like to look at things like current draw on a motor. Maybe I'd like to look at vibration. So what was a repository for the actual downtime and loss events and nothing else.
So a good example here, Zach, would be at a very simple level would be manufacturing apps by PTC, say 5 years ago. Manufacturing apps from PTC had a limited suite of machine states. In fact,
that's how it's storing it in the database. So it's kind of making your data useless down the road. Kind of.
It's a weak OEE model because first layer state, first off, was finite. There was no customization whatsoever. You had to choose from the option they had available. But what he's also referring to is second level. So that is where if a state, then I can look somewhere else for a deeper cause.
Yeah, like cascading downtime and stuff like that, like among cells, or
just.
Well, even within a single machine, you might find that the real reason why there was a product jam was because a bottle was overfilled.
Correct.
Right. So if you don't have something that lets you look at all the things that might relate to the failure mode, you still get a head start. Don't get me wrong. You know, first layer downtime.
Then the operator would have to like customize that event. No.
Yeah.
Right.
Or they'll handwrite something down, and you get the handwritten version of the PLC code mess.
Yeah, you get it as a comment. You get it as a comment on the report where downtime is coalesced to this, but the comment tells you, yeah, that's not actually what it was. It was this other thing.
Because the OE model doesn't account for
it. Doesn't account for it. That's where the weak.
That makes sense.
So the second reason MES is hard is legacy systems. So many manufacturing facilities have legacy systems and equipment that may not be compatible with modern MES solutions. I would argue, I mean, if you're still using hardware that's talking serial communication, I don't see it that often anymore. I mean, at minimum, everyone's at least to the data highway plus level, and you know, you can gateway that. But for the sake of argument, there are still facilities out there that have basically no mechanism to talk to smart devices in the field.
That's true on the other side too. We're still, you know, I've got a customer who's running a deck. They're trying to find a way to emulate an old VAX operating system so they can keep running something from an old deck system which supplemented a certain kind of mill. So that legacy systems issues on both sides of the equation.
I mean, I remember I worked in steel a long time ago, right? That was my third stop when I worked for the end users. And this is a perfect example of the challenges with legacy. We were using old Texas Instruments PLCs, and the only mechanism we had in place to interface with those TIs was we had to install a ControlLogix PLC, and then instead of rewriting all the logic, because that would have been, you know, n times 100, it was going to cost us n to just interpose all the events and use a ControlLogix PLC to just capture the paralleled field connections and then write business logic. And that's literally how we acquired the data, you know, where that cost us, say, $80,000, but to do a complete rip and replace on the stacker, which is where we had two TI PLCs running this old $20 million stacker, that was going to be like a $5 million, you know, project. Right. So it was
20. Are you sure this was a long time ago, Walker? You could be describing something one of our team was looking at last week.
I have a question.
But this was 2008. So for, you know, but not that long ago. Go ahead, Zach.
No, I will say I actually do like your comment. Like, it was pretty very nice. Like, you guys are just talking at both ends of different extremes, and like I think you guys agree more than you disagree.
Well, there is a thing that jumps out. Okay, so from a theoretical level, I agree with Sean, but I deal more in just, you know, like the first thing that I thought about when he talked about, you know, an organization that, if they approach it right, they build their facility right, okay, then what happens in the case of M&A then, right? You know, where they didn't have control over how it was constructed. Well, then you still have to have a solution without spending $20 million.
Like
right?
the simple example was like, yeah, there's a lot of MESs that are off the shelf that are highly customizable, which kind of the original post kind of made it seem like that wasn't even a thing, right? So like, I honestly, it does seem like to me like that was just a distillation of what your original, what you said in the video, and kind of hyperbolized for engagement. But I do have a question though.
Well, hold on real quick. Let's use this example. You have a food and beverage background, right, Sean? So
yeah. I became a food and bev guy because of all my well-known food and bev companies that made cars and steel and paper.
So we're just finishing up a large food and beverage MES transformation that 40 plants. I don't know how many employees. I think it's 10,000.
Yeah,
it's a lot. It's a big
small with 40 facilities.
Yep. And with our approach, which is built on this concept that you always end up building, right? Yeah. That doesn't mean we're not buying off the shelf software. We have, we're using Ignition, we're using HiByte, we're using EMQX, MQTT brokers, and then we're interposing with some off the shelf software that they have. The total spend for a organizational wide MES deployment for this customer has been $1 million for 40 facilities over a 2-year period, 22 months. Okay. I did this a really long time, and I've done this a really long time, and I know that those numbers are preposterous.
What, the 40? Not the packaging one?
No, not the packaging. This is in
oh my god, that's insane for $1 million.
This is the bakery company. So this is $1 million total. Insane, dude. Total spend is $1 million. I just looked at their account. So
that's an 8-figure project.
Yeah. It's an 8-figure project all day long. And my point was the concept, and I think Sean and I agree here, especially on the data modeling piece. I think we definitely agree that's the ingestion point. The data model that is the ingestion point of the data is the most important. That's the abstraction. That's the object that is repeatable.
You got to do that somewhere. There are a few different ways and places you can do it, but if someone doesn't take that time to think about imposing a model around that. And the funny thing is what that actually means is they've stepped back and they've thought about what is this process? What's worth knowing about it in terms of reference data, things that are immovable about it, what's worth knowing about it in terms of variable data. And once I've defined that, and then the same concept, the same method of thinking should go around materials and actual production units, and even to some degree people and skills. If somebody's gone to that level of effort, then it actually becomes a lot easier to make the choice. So you can say, I'll have something on the edge like a HiByte that does repackaging, even some pre-handling and pre-processing, if the other parts of my stack are best served by that. And many of them really are, right? Again, I wear a certain logo near and dear to my heart. Doesn't take too much work to figure out which one it is. But if I take a look at a lot of the customers that have got other stacks, and if the right thing to do is always to gap fill and enhance rather than rip and replace, people who take that sort of data ops approach to the edge can solve a lot of heartache. And it's not just the mechanics of the tool. It's the fact that they actually sat down and said, and this is funny, I do want to come back to that whole question about the ERP model, because I actually think it's worth me explaining why I was such an undiplomatic you-know-what.
Yes.
And normally, I'm really not. Normally, it takes 2 comments before I become a complete twit. But
yeah, I'll come back. I'll read your reply right after this your comment.
But just to finish off that thought, you got to do that work somewhere, or you do it the wrong way elsewhere. You either figure out model and where it should live, or you write really bad code in your UX, or you write really bad stored procedures or the equivalent in the database.
Agreed 1,000. What I argue is the place to do that is right before the data gets to your unified namespace. But I also argue that what you should do is ingest it in the form it's in. So if I've got 2 PLCs written by 2 PLC programmers that do exactly the same thing,
yes, I
should be able to navigate into my unified namespace, and I should be able to see the raw data structure from the edge device of edge device 1 and 2, and then the abstraction, the model that I've created that I'm then going to map and abstract and normalize from those 2 completely different PLCs that serve the same function. I have one function.
You keep knocking away the things where I thought we'd get to have a real fight.
But let me say, so here was your reply to my comment, which was there's nothing in there that wouldn't fit within the order management, BOM material, route operation, and spec models in several decent MES platforms systems. Yeah. The overlap parallelization aspects of their scheduling are similarly well solved by a number of FCS vendors. I'd argue that this customer can save a lot of ERP investment precisely by reverting to a normal ERP side footprint and taking advantage of the configurability of operational models and constraints in FCS MES combos. What I will say is this, and I didn't explain this, with this specific customer, they were in the process of deploying a off-the-shelf ERP. They had gotten all the quotes. They were looking at $500,000 in licensing just for the ERP system. We did the full business for about $1 million. Yeah. So, and they would have been at, let's say, conservatively $2 million total cost of ownership had they gone that route. Yeah. We were able to do the whole business, not just the ERP layer, but the whole business for about $2 million. Now, granted, there's no vendor to go call to support it because it is built soup to nuts. It's in a common platform that is supported by a vendor, but it is built soup to nuts custom. You continue. The uniqueness in this system is entirely in the visualization style, which is UNS to, we're basically doing informative objects out of the unified namespace. And while one can argue whether it makes sense to bury unique IP in a highly tailored presentation layer, it's easily enough done. Some MES vendors even provide low-code tools for their own visualization elements, generally offering pre-built hooks to the reference spec data and event data in their own core, and also usually offering the option of going freestyle with HTML5 and various API tools for external data sets if desired. As far as the correlation of unit-level process data to specific orders goes, that's not as commonly offered as standard, but it's out there in at least one really good MES solution. Let me say this, your second to the last paragraph there. I agree there are options for hooking into off-the-shelf solutions to do what we were doing. What I'm saying is the cost to benefit is such that you can't, that's the thing that gets left behind, because the value I get out of that integration isn't worth the time and the money I got to spend to get that integration, which is why we preach the UNS concept so much, that all data matters, and that the big thing that you have to do is come up with a structure for your business, define all the functions of your business, and then define all the operations of your business and create namespaces for them. Let me go to this next piece and then I'll hand it over to you. So I replied and said, if we define MES as just the core four of OEE, downtime tracking, work orders, and scheduling, this is simply not true. There are no off-the-shelf MES systems that provide all MES capabilities for all businesses out of the box. And by the way, you did acknowledge that in your last sentence, but I didn't really acknowledge it. MES is always built. This is because when organizations are not constrained by the limitations of MES or ERP when they are defining workflows, they go where the efficiency can be captured. They pay no attention to clean event triggers or encoded state registers or even linear manufacturing steps. And what I mean by that is B doesn't always start after A, but sometimes it does, right? So, and if you treat A and B as separate objects and not one that inherits from the other, that's fine, right? You can have B start whenever you want it to and A start whenever you want it to, but not everyone does it that way, which is what you're saying. No off-the-shelf system is developed for manufacturers to configure their operations as they are, rather than as the platform expects them to be. Come on the podcast and let's debate it. So I'll turn it over to you. We had two more. We had two more exchanges, and I will read those here in a second. But I'll turn it over to you for your comment.
Yep. Yeah. And I think that this is where I wanted to come back to the original thing that, in all fairness, probably set me off worse than it should have, which is what really is the difference between the way a good MES lets you define your operation versus what's in the ERP. And again, I've done a bit of homework and listened to a few more of your podcasts and looked at some of your YouTube content, and there are a couple of things that I do see a little differently, right? There's been statements made that effectively, if the ERP or the PLM has got a defined, bill of material and route structure, that's too rigid. And I would argue that, yep, that can be true in the ERP, but to your point, my view of MES was really that it was born precisely to say, look, if in general I can't assemble a car, till I've got a frame and an engine and quarter panels and the like, there's absolutely some rigidity there. It's really hard to, you know, make the chair first and then, you know, build the car around it. However, the two things that were at the back of my head were the whole point of MES, and again, I say this as an OG, right? I found out the hard way that what we'd written for the steel company back in the 90s was an MES when someone told us we'd written one, to which I cleverly replied, we wrote a what? So, you know, and I'm told that the term was coined in 1993. So that kind of, you know, for all of those of you who don't know me, my beard is white, not just gray. So for me, there was that whole issue of, well, the whole point is actually to be able to say, what if there should be parallelism? What if there should be some ability to flexibly sequence things so that you can get sub-assembly here that then synchronizes back to a main assembly? Or even things like, what about coordinating make-ready work around thin film extrusion and printing and conversion? So the whole point of the MES was to say, yeah, from a costing perspective, this is very linear. In terms of the final good, whether you're fabricating, assembling, or going through some other kind of process, there may well be a finish that obviously has to come after the start. But a good MES would let you say, no, I can do this in parallel. I can do this as a group. I can create this as a whip pool and draw from it and differentiate further downstream. And the second thing that's always at the back of my head, because I usually have this argument with accountants and finance people, we all know that to a finance person, and forgive me, any of you who may be on, bless you for being here and learning new things if you are.
There's actually one member of our community who is a finance guy, and there's only one of them. So,
all right, well, there you go. But I studied accounting and finance at night school for 3 years because I got tired of CFOs killing my deals because I couldn't communicate to them why they were worth doing. And what I learned was, and let's pick on food again, packaging is a cost center, right? Now, to people who are engineers and MES people, packaging is somewhere between 3 and 17 or 18 individual assets, each of which has its own unique contributions to make to losses for quality, losses for downtime, some of which have a contribution to make to the question of optimal sequencing and scheduling. So if I think about why MES was born, it was also to break that rigidity, to let somebody say, packaging is a cost center into which I consume labor and aggregate chunks of material. That may not even understand the fact that I've got N packaging lines, let alone that each of those lines may have a slightly different configuration, be good for making different things. So fair or not, part of why, guess what set off my bullet, a red flag reflex, was, hang on, MES was born precisely to decouple from the over rigidity of MRP and DRP. And it was probably just the awkwardness of the phrasing that caused me to be rude when I picked up that gauntlet.
Well, but at the end of the day, and I say this all the time, that it is about how much we spent and how much we made.
Yeah.
Right. I mean, all of it. Why do I calculate TEEP? Why do I calculate OEE? Why do I care what a cost center is? Why do I not? It's all, it boils down to how much did I spend and how much I make. By the way, this is the reason I get so frustrated with the ESG arguments, because I'm like, as much as I think ESG from
social credit points,
as much as I think that ESG is, from a philosophical perspective, is a good thing for humanity, from a business perspective, unless you somehow tie sustainability to the bottom line, then no business actually cares about sustainability, right? It's the same thing with safety. No business actually cares about safety except for how much it might cost them if they are not safe, right? Yeah. So it is about money. It is about revenue and cost, right? Yeah. What I've always argued is this: everything you need to know about your business is on the plant floor. There is nothing you buy. There's no money you spend in a manufacturing operation that isn't designed to support operations in some way, whether it's 2 levels above me. It's still there to now, in vertically integrated businesses where the link in the supply chain from here to here is kind of fuzzy. That can be a fuzzy statement. But in manufacturing, everything supports operations. So why is it that our data acquisition and our structure does not start there? I've never understood why it doesn't start on the plant floor and then have our business systems be a reflection of reality, instead of our business systems being a structure that we are asking our operations to try and fit into. I've never understood that for the life of me, which brings me to this question, Sean.
Yeah.
can you give me an example? You had said where a good MES would be able to do this. Could you give me an example so that you don't have to pick just one? Can you give me 2 or 3 examples of what you meant by good MES?
Yeah. Okay. So I really didn't want to come on and shill.
Right.
You've thrown me a bone.
Okay.
So for those of you who take a look at Novotech and you clock the GE digital connection, you'll spot prophecy plant applications. And if I'm honest, God, 17 years ago, I'm old enough I can say things like that, and that's only about half the career now. So about 17 years ago, I was working for one of those SIs, and it was actually an SI that had given birth to one of the OEE packages. And prior to that, I'd worked with a different one. Prior to that, I'd had my own MES business. So by that point in my career, I had played with DataSuite, Intrac, Camstar, Teradyne, Bespoke, right? By definition, we wrote an MES of our own. That started as a custom project. One of the SIs I worked for had delivered, by the time I joined them, over $60 million worth of bespoke MES to certain businesses that shall remain nameless. So I'd had a hand in a few, and I came at it with, the abstract data modeler's view from a finite scheduling and MES background. And then one fine day, a chap named Carson Drake from Gray Matter Systems was giving a bit of a demo on plant applications from GE. And I literally sat there and went, holy beep. I haven't seen something that elegant in terms of abstracting away from the mess at the edge to a very flexible, definable set of event models for production consumption, for defining specifications that relate to products and process performance, and essentially allowing somebody to compose a plant model where you can be self-measuring wherever there's automation data to flow that gives you good enough places to hook in your PLM or ERP master data. And it did it in a way that was just, I'll quote a colleague of mine who worked for a well-known food company in the States, then went to work for GE alongside me, and then went to work for one of my former employers. So we're doing a job for a company in the business, and it's going to cost about $3 million. By the way, when I do that, I mean cigarettes, not weed. I realize it's been a few years. And he said it's going to cost about $3 million using this other company's platform. If I was doing it with Plant Apps, I could do it in less than a year for $800K.
So I don't dislike Plant Apps. There are a couple of problems that I have with Plant Apps. Number one is cost.
So I got to roll up my sleeves here.
So one of them is cost. So we did so Plant Apps was one of this bakery that we went against.
Yep.
Plant Apps was who we went against. We went against GE. Okay.
Mm-hmm.
And there was and you know who I'm talking about?
I probably do, but I'm not going to say anything out loud in case I'm wrong. I'm not that close to the American side of the organization anymore.
So here's what happened. They come back. The customer comes back a couple of years ago and says, GE has presented X. Here's what they want to do. Okay. It's going to cost significantly more than what you guys proposed, and tell us the reasons you shouldn't do it. And I don't want to take shots. By the way, I love Plant Apps. Let me say something here. I love Plant Apps. There are a couple of issues, like scenarios where I wouldn't use it. Yeah. But in terms of an MES platform, I actually think it's a great platform. I think it costs too much. That's my problem with it. That's it. Okay. But there is a unique situation that you would have a problem dealing with, and that is one of the things I tried to do in Plant Apps was I tried to do an example of a process that I had that was a bulk process that took 20 minutes to go from ingestment point at the first cell of the line to the stacker. Okay, it took 20 minutes. There was a bulk process, a mixing bulk, and then there was basically a cutting process, and then there was a batch packaging process. You had multiple work orders running on that line at any given time.
Yep.
The problem is there was no rising edge of when the work order changed. So Plant Apps could handle multiple work orders on the same production line as long as multiple work orders on the same production line was consistent. That is, the rising edge was consistent. And this wasn't. You could have the previous line could be 80% of the way, the previous production order could be 80% of the way done and the new one started, or it could be 30% of the way done and a new one started. And so being able to associate counts and state to the correct work order was problematic in that unique case. Okay.
Yeah.
Here's the issue. The issue is with not just, and I don't want to take a shot at Plant Apps. Again, I love it. Okay. My point is that what we advocate for to customers is, why does MES exist? You brought this up, right? MES, the reason we call a thing MES, all MES is a suite of functions. That's all it is, right?
Yep.
And the reason we call them manufacturing execution is because of the way we used to do things, right?
Yeah. Yeah. We used to only count the beans after the fact, and we used to do all the testing after the fact. And up until that point, it was paper and prayer that built us a bridge.
So why is it we don't go down to the floor, collect all of the events, and abstract the functions as they happen? That's always been my argument. My argument has been put everything in a unified namespace, and then I write an MES function that consumes data, creates information, publishes back to the unified namespace. That's my point. The issue, by the way, I love plan apps. I'm definitely not going to bash it. If you had brought up, say, I like Traxxas as well, but if you were going to bring up, say, PTC solution or something, I'd be, come on.
Oh, yeah. No,
I like out there, I want to give off-the-shelf solutions some credit.
Yeah.
I like GE's plan apps a lot. I really like Tulip. Tulip is not really an off-the-shelf MES solution, but it has off-the-shelf MES capabilities. I'm a huge fan of Tulip, by the way.
Yeah.
I like, well, I'll leave that one off. Let
me throw a thought at you, because this is one of my personal flaws. If you were to line up a bunch of my colleagues and say, what is it Sean does that really pisses off customers, even when they know his heart's in the right place?
Yes.
Okay? And I'm hoping some of them are on and they chime in right now to see if what I say jives. And it would be, sometimes I try too hard to look a little too far ahead, and I can be a bit of a jackass about it. So what do I mean by that?
Well, that makes you a good architect then.
Yeah. Well, live in real time, we're doing a rollout. The solutions arm of our business in the UK is doing a rollout for a company in the food sector where 2 years ago they said, we want no OEE solution. And I said, that's great. Then what? And they got mad, and they had every right to be. I was in a mood that day, so I wasn't diplomatic, because they'd said some things where they were oversimplifying their own usage of the tool.
Right.
And this was important.
Because what they want is a function of what they know right now.
Bang on, right? And, once somebody starts doing something, then they're going down a maturity curve, and then they go, shoot, maybe I would have asked for something different. If I had known, if my business is digging holes and I'm the best at doing that with a shovel, the minute I know a JCB digger exists, my understanding of what I need changes. But if I don't know it exists, I want a bigger shovel.
Exactly.
So I asked him, then what? And there was a reason. There was a classic disconnect between business leadership and a couple of their, I'll call them plant managers for lack of a better term, although their responsibilities are a bit broader. Well, once we've got the OE, then we'll know our top 10 reasons for downtime. And I said, okay, then what? Right. Well, yeah, but then we'll know. And I said, how do you envision using that? And they came up with some answers that were good and some that weren't. But I said, look, ultimately what you're telling me is you haven't thought ahead to the fact that in your business, raw materials are probably a bigger problem than the underlying maintenance and care and feeding of your assets. So if you buy a one-trick OEE solution, you'll feel great for about 6 months. And then you're going to do one of two things. You're either going to try and bend that OEE solution out of shape and start adding things to its data model that were never intended to be there.
Agreed.
Or if you're actually, really good at looking in the mirror and going, hey, that was actually a great learning experience, and it's okay to throw it out if it makes more sense to find something that helps us drive execution from which the metrics are a byproduct. And I think that in a lot of cases where a full solution can seem expensive is if you get an opinionated twit like me going, I hear what you're saying about today and tomorrow. What I'm worried about is I'd rather put you on a path to look after next week, next month, next year. Now, you don't need to buy every piece of that solution today, but by God in heaven, you should work backwards from where you're headed, not work up from where you are.
Well, here's something no one's ever heard me say publicly before. I do this actually when I'm talking to clients. Government makes laws. They don't get rid of laws. So every year we add new laws, and we never get rid of any old ones, right? Yeah. Okay. Do we have lots of old laws that we could get rid of that they don't even apply anymore? Like in New York State, it's against the law to walk in front of your horse. I mean, there's a law on the books that says you can't walk in front of your horse in New York State. We don't even use the canal system anymore. So it's pointless. They even have that, right? Well, I'm not in New York, I'm in Texas, but I grew up there. But the same thing happens in digital infrastructure, in digital transformation. clients never think about the fact that I may build a solution to solve a problem and never need that solution ever again. Okay. In England, you can't carry a salmon suspiciously. So one of the things that I often talk to customers about is you may build a solution to a problem you have. And then once you solve the problem, you don't need the solution anymore.
Yep.
Okay. And have you given that any consideration?
Yeah.
Have you thought about it in any way, shape, or form? And a lot of this has to do with like stuff you do on the edge with green grass, Lambda, that kind of stuff.
Yeah,
but
yeah.
at the end of the day, solutions are not finite. They're not eternal, right? They evolve. Organizations evolve. And we talk about organizations, what you want as a function and what you know. Let me say this. When we build MES, if we use an off-the-shelf MES module, and sometimes we do, I would say 40% of our MES is off the shelf and 60% is built. And I would say there's never a scenario. And when I say MES, I mean functions. I mean, there are hundreds and hundreds of possible functions in MES.
Yeah.
When you're building an MES, is that a fair, say you're obviously Plant Apps is your,
yeah, it is one of my favorites, but I'll answer it this way. So funnily enough, one of my colleagues, we were chatting about this coming up, and he asked me why I had such firm opinions. And to be fair, I've got other colleagues that are like, are you sure you're not just an old fart who's married to what he learned 30 years ago? So, you do what you do. You go have a walk and you look at the trees and you listen to the snowfall. And then I came back to the fellow and I said, well, this is why some of my opinions exist. And he said, great, say that again. I'm going to record it. And we're going to do a follow-up on that because there might be something useful. So one of the key things that came out was the data plumbing is the most important thing, right? Because in my experience, where customers of all levels of maturity want to dig in and argue is on what they think of as reporting and what they think of as UX. Now, why does that matter? Because I think a lot of the frustration around, can you ever get an off-the-shelf MES that fits the customer? I think that the smoke and the noise that comes from people being upset about, oh, your out-of-the-box report isn't great, or I don't like the way you offer me this standard function for reviewing whether or not the quality parameters are healthy. I would prefer it if this column was on the left and if the background was pink. And I've had a payment held up for reasons that were no more serious than that. I think that can distract from the fact that, in my view, when you buy the right MES package for the customer, and right means two things. Do they have enough holes that they shouldn't be buying point solutions to fill and then just integrating around that through whatever method, right? There's been a lot of customers I've talked to and then said, you don't need a Plant Apps or any MES. What you need is a point solution here and some means of creating what we would now call a unified namespace to support reporting and analysis. But when somebody has enough need, then I'll look at two things. Can I give them a 50 to 60 to 70% head start based on the strength of the data model and its ability to handle the work processes? So for why I love Plant Apps, it handles rework. It understands parent-child relationships. You don't lose your traceability. So if I'm in a highly regulated sector, I can have all that flexibility of, whoops, I buggered up this batch, but I can dilute it through the next 20, and I can still trace back to raw material. So if I've got a certain kind of end user and that kind of thing matters, what I'm looking at is the data model and the database engine and the way the transactions are created and logged. And if that hangs together, what I'm really after is 60-ish% head start compared to if I had to sit down and build it myself from scratch. Now, we both know enough about Plant Apps, know it does a nice job of letting you have a data mess on the PLC side, so it gives me leverage that other MESs don't.
Correct.
I had one customer that looking at making two changes to a report they wanted to run. Single business unit, 20 factories using Plant Apps, 20 using their homegrown MES, which had the same sort of architecture and data integration to the shop floor methods as a lot of others. $2 million to upgrade their custom or enhance it, 80 grand, including putting in the sensor in one of the factories that didn't have that for the 20 factories with Plant Apps. So I would argue, again, if you buy the right tool, you get leverage on cleaning up and coping with the mess at the edge. And if I've got that, customers, if you're listening, forgive me for what I'm about to say. I don't care if you're unhappy with the standard UX because I can resolve that with a low-code tool. I can resolve reporting with the tool of your choice because my core data is clean from an event perspective and from an audited perspective. And if it's clean from those perspectives, I can build whatever the heck you want over here. And if I can get you that by also saving you the need to reprogram every PLC and SCADA to present data perfectly, it's a win. And again, now that we've chatted, I get more of what you say when you mean build. And I think we'd agree that you're never going to get 100% fit out of the box. But by God, if I can get a 60 to 70% head start, and if I'm dealing with a customer that doesn't have a terribly deep and broad skill set in data architecture, communications, integration, I'm better off giving them that prefab house than telling them, here's what a digger is for, dig a foundation. Here's what a concrete mixer is for, pour the foundation. Here's what framing and you know, well, heck with framing. Here's what sawmills look like so you can cut your tree down and, you know, get yourself some 2x4s and 2x.
Let me ask you this. If you think that way, and I believe you when you say that you do, and I want to add one quick thing. I have never, to me, the platform is not important. What's important is how the platform functions. So does it use open protocols? Does it prioritize an event-based engine as opposed to transactional or a poll response-based engine, right? Is at its base level, is it easy to work with? That is, I can teach somebody in 2 hours how to build a visualization from data I can point to. But at the high level, is there no limit to what it is you can build in that platform? That's basically how I evaluate platforms, right? Let me ask you this. If you think the way that you think, then why are you not an ignition guy? Because you're speaking, you talk like an ignition guy. I mean, you really do. Like ignition. And by the way, I get it. You know, I don't want to put you in a weird position with the plan apps thing. And let me say this again. I like plan apps. For me, when I look at total cost to ownership, it's I can never end up making the recommendation because it costs too much. Right. And
I think that's a function of where the customer may be on a curve. But let me answer that question point blank.
So what you're saying, is that you're paying with plan apps, you're paying money that you would pay 5 years from now. No, what I'm saying, and you're paying 5 years later. You're not paying.
You should still be able to stage any program so that you're getting genuine payback quickly off the right size investment at the right minute. What I will say is that you are, you get a lot of infrastructure under the bonnet early that you can then choose to use or not. Whereas with a lot of others, you get what you get the minute you get it. And I will say, without picking on any particular company, but I've seen a few names go by, we're winning deals back because as the customer's understanding of their own actual needs grew, they went, shit, I'm in a corner. Pardon my French. And that's where we're having people come back and say, yeah, I thought this was a great idea, but now I understand how to tell you I need a JCB digger, not just a big shovel or a shovel and a rake. And that's arguably, and I'm not kidding when I say one of the things I do that can annoy customers is go, but dude, what about 5 years from now? We need to think about that now. Otherwise you will spend money twice or possibly 3 times. And whether that's ripping something out that was too light, or whether it's trying to bend an imperfect solution and badly out of shape. And then just to put some context, where that usually happens is around things like whether or not materials themselves are properly characterized and whether or not you can actually apply, process center lining and process stability measurement, not just basic execution and some of the performance metrics, right? There's lots of good packages out there that can fit in around the edges of some SPC here and some whip execution or OEE there. But if someone has big enough holes, and again, this goes back to when Carson did that demo. Carson, I know you might be on, so this is all your fault. When he did that demo, I genuinely, as a data nerd, went, I can't do that with almost any other solution I've seen. And I've had a hand in building a few, and I've had a look under the bonnet of a fair number. And that's why I let GE steal me. They said, we see growth. And I'm sitting there as an MES nerd going, you're damn right you do, because what you've got is something under the bonnet that is an unfair advantage over most of the other competitors if you're looking at the customer over the life cycle of their supply chain integration and continuous improvement program.
So let me ask this one more time. And this is probably as controversial as I'll get. I mean, I'm trying to be.
I reserve the right not to answer.
Okay. Yeah. Is the company that we were working with, they the total cost, like the plant apps cost relative to what we spent, it was like a 9-to-1 delta.
Yep.
It was 9 million versus 870,000, and I think we've done 130,000.
And that's for total delivery, including service.
Right. TCO support, right? Now, that doesn't mean that for $9 million, I'm not going to get a good solution, right? It's not. But if I can get the same solution for $1 million, why am I going to, or if I'm going to get the same functions, let's not say same solution,
but yeah,
if I'm going to get the same functions for $1 million, why am I going to spend $9 million? And now I know, and I don't expect.
But you're saying that depends on where the customer is on a curve of like their technological capability. Like, so like I know the customer is like not, they're savvy.
But this is different. If Walker's saying, you know, look, I mean something, yeah, Walker's saying that that apples to apples, if I need it to do X and both do X and one costs me, you know, 11 pence and the other one costs me £1, why the hell would I pay £1? That's a fair question. And unfortunately, the only answer I can give is without really understanding that footprint and what the customer's after. The one thing I will say is it is with any application, it's entirely possible to bring the wrong methods to bear. I don't believe you guys would do that because of the way that you think about modeling and data abstraction.
Right.
But I've had the opposite experience, you know, where you know, setting aside the one of the established install base, I think about when my colleague went to do that other project and he said, I can do it for less than 1/3 of the money and less than half the time. So for me, I cannot believe that there wasn't just some sort of misreading of how to apply the tool or whether or not
I think
be a mismatch.
And again, it's not fair, you know, because you don't know the details of the project, so it's not like you can't speak to the details, right? But I want to ask 2 questions, and we'll call it a day.
I have a question too.
All right. Well, let me say this one thing. I think where the height of the cost was, the licensing. The licensing alone was nearly $1 million. The proposal was nearly $1 million, whereas the licensing for our solution ended up being, it was in the 200,000. I don't remember what it was, but it was a couple $100,000. There was like a 4x cost on licensing, but again, that may not always, it's not always going to be 4x. It really depends on architecture, right? Yeah. So that was first piece. The second piece was, I know there was a ton of engineering that was having to go into data abstraction. I know, and I know for us, data abstraction wasn't that problematic because of the approach we were taking to ingest all raw and then use the same abstraction model. So I think maybe this is a case where it's not a fair comparison, but that's the first thing. The second thing is this: would you describe your general approach to MES, or the way you recommend customers to approach MES, is that you start out with a platform for solving problems and then you build business functions?
Yeah, I think that's probably not a bad way of putting it. I guess if I was going to restate it, I'd say I want to know what you're trying to accomplish. Because if somebody, meaning the end user's business, because if somebody says to me, my goal is product and process innovation, you know, my goal is supply chain agility, you know, minimizing the amount of cash tied up in inventory and getting rid of, you know, expedites. You often will apply the same tools, but with different emphasis and different nuance compared to somebody who just says, "Hey, I'm the lowball producer of commodity product." Right. So I always start there, because the strategy for me is going to be what dictates what are the things that they may not know how to think of, but that I can then look at all the experience and say, well, here's where your but did you think about comes into play, and that's where you can end up saying, well, you know, yeah. If you think all MESs are alike, and I've got customers who thought that way.
Yeah, most of them do.
and you know, to be fair, there's all of us vendor side people use the same words to describe things that are actually very different under the bonnet sometimes.
Yes.
So if you think they're all the same, then it gets really easy to kind of tune out, and it requires somebody to kind of say, well, hang on a minute. If your game is product and process innovation, then you need the ability to take a recipe from a lab or from an idea in a scientist's head and define it in manufacturing terms and then relate it to existing manufacturing units and processes quickly and easily. And that's a very different game that you're going to accomplish with a tool like Plant Apps compared to something which is only focused on whip execution and doesn't really think about detailed specs and process. Yeah,
we just did this with a life sciences company. when our architect presented to this life sciences company in their PMDM area, which is their research and development area, we had fully integrated the entire stack of data. So from enterprise, cloud, ERP, historian, manufacturing execution, all the way down to the plant layer. They thought we were just going to be integrating with the historical data in their OSI Pi database. When they saw that all data had been consumed, ingested, and in many cases already transformed, they couldn't believe that that's what was done in the proof of concept. They were like, wait, every other vendor we brought in, or every other approach that was attempted, only provided a fraction of what you did there. And what I said was, the platform we're using and the strategy is what makes it different. We operate under these concepts that all data matters, okay? And you make no assumptions about how it'll be consumed. Worry about consumption later. First thing you have to do is acquire and model, right? It's connect, collect, store, analyze, visualize. That's what you do. All right, Zach, go ahead and...
I'm sure you're not looking at our product wheel that we use, not product wheel per se, but sort of a conceptual wheel. Our marketing team came up with something that's very similar.
Let me say one other thing real quick. In that implementation, we do integrate with GE Plant Apps, by the way. So it is a synergy. There are scenarios where Plant Apps is in there. I like Plant Apps. I don't want anyone to go away from this podcast thinking I don't like Plant Apps. I do. I just think cost is problematic.
Would it be fair to say that you don't view Plant Apps as a competitor, but you view it as a node in the ecosystem?
Yeah, I would definitely say that I don't see it as a competitor. I view it as a node. Go ahead, Zach.
All right. All right. So no, I really like this conversation in the comments. Like they are agreeing that they want to see more of this type of open conversation and dialogue. So my question is so when you were talking about the finite scheduling thing, I couldn't help but think of the example or the riddle, like where you have 3 burgers that you're trying to cook on a grill that can only hold 2 burgers, and each side takes 5 minutes to grill, and you got to grill both sides. Finite scheduling is you grill it in 15 minutes, right? So the question of finite scheduling, like how do you see, I mean, it's 2023, we can't have a podcast without talking about ChatGPT or AI. Like, how do you see AI actually being implemented within the area of finite scheduling, being able to find these scheduling optimizations? And
see, it's interesting because algorithmically, they teach kids things in second-year university that we found out, again, by accident, that we were pioneering. I kid you not, I had a Penn State U professor. We actually had a garage business, okay? I tell people, I dropped out of uni, joined the family software business. I'm like Bill Gates, but without the billions. And we had a guy knock on our door, and he says, I understand you guys have done some work with genetic algorithms for search space reduction in the finite scheduling realm. And who are you? And he said, I'm Dr. Lou Hafer. And I'm like, okay, nice to meet you. Why are you here? He says, nobody's done this before. It's supposed to be impossible. So I haven't looked that hard. So the thing with AI, I think it's different maths, right? And bearing in mind, I'm more of a data modeler than an algorithmic guy. So I may say things that mathematicians in the audience will laugh at.
No judgment. Just we want to hear what your thoughts are.
I do just think that it is different maths because at the end of the day, so shorthand answer, again, apologies to people from many scheduling vendors. Most finite scheduling systems are not really terribly algorithmically driven. They're using a simplistic calculation engine that basically says, show me the due dates for all my products, and then let me use due date as the determinant of how to calculate backwards and create the least amount of lateness in my schedule. Most of them don't actually have the plumbing to say, if I've got 23 extruders and 6 of them can do a maximum thickness or maximum gauge on the bubble I want to blow of 8 millimeters, but 4 of them can only do 4 millimeter, and some of them can only handle this much recycled content, but others can handle this. And if I can actually change my base resin blend and additives to get the same physical properties out of different extruders with different ratios, and oh, by the way, if I blow a J tube versus a C tube, I can actually convert both to this kind of product, but not that. Most finite scheduling systems can't solve that algorithmically.
That's why I'm saying, wouldn't an NLM, a natural language model, be able to take what you just said and incorporate it into the schedule.
I don't know if
Like,
an NLM could do that terribly well, because fundamentally what you're trying to do is to convert the product characteristics and the machine capabilities into something that can be driven more mathematically from an algorithmic perspective. And so that's why the genetic algorithms essentially said, if I start with an infinite search space, the minute I put one thing into the schedule, I've just cut my infinity at least in half. The minute I try, and again, with the way the algorithms work is they start off a number.
Right. It's sort of like
you're scoring the health, right? Am I getting a sequence that I'm minimizing changeover when I put the second job here? If this is more survivable because of its health score, then I'm going to keep following that path. This one is less survivable underneath a threshold, so I'm going to kill that off and put my processing to further this exploration. It's a little different.
Right, because mathematically what you're saying is almost like the traveling salesman problem. Like, it's an infinitely problem that computers would spend billions of years to try to solve. Is that what you're like? Is that what you're saying? Finite scheduling is
and that was
problem
it's not entirely that, but you're not wrong, right? That was the use case that people held up. It is a variation of the traveling salesman problem. It's just I'm not sure that natural language models are going to be the ones that solve that. Because
Walker, you have any thoughts?
Yeah,
computation works better on numbers, and that's why I'm not sure about that natural language models. If you can create numerical relationships between a product characteristic and a machine capability, you get faster math.
I've been testing some of this with ChatGPT, and what it requires, and I'm only using ChatGPT right now, and what it requires is that I give ChatGPT the constraints. Yeah. So one of the most important lessons anyone can learn with ChatGPT. Here's a little insight into our ChatGPT workshop next week. One of the very first things I'm going to talk about is stop using it like Google. Okay. Okay. ChatGPT treat ChatGPT like the smartest person you've ever known in your entire life. And what you want to do is you want to narrow down ChatGPT's vision to only the things you want to talk about. So you tell ChatGPT who it is, right? Yeah. So if you tell ChatGPT what you are is going to act as a model, my supreme scheduler, okay? And here are the constraints of scheduling. Then you can feed it language variables and parameters that which it will run through its constraints and give you a recommended adjustment. Okay, you can do that. I've been testing it. It works fairly well. It's still early. I see a place for NLP, but I think the technology is moving so fast, we're never going to have the point where you're going to input the variables and the parameters. You're not going to give it the constraints because the solution is going to plug in natively somewhere. Yeah. I want to close with this here. I want to read my one last thing that I think kind of summarizes, which was when I find, Sean graciously said that he would come on the podcast and tee it up. He said, go ahead and tee it up. And I said, before he said that, I said, come on the podcast and challenge any of my premises. Yeah. You will not be able to provide an off-the-shelf solution that doesn't require the client to roll back that which gives them their competitive advantage in service of fitting into the solution. If I add in the caveat there without some level of customization or forward thinking where you're prioritizing raw events from the edge, then Sean and I are speaking the same language with that qualifier. So why? Because manufacturing operations are not linear. This is a really important point for everyone who's out here, right? Even linear manufacturing operations are not linear. Yes, you can't build a car without an engine or a chassis or a frame, but there are hundreds and thousands of steps between the creation of those subassemblies and the assembly of the car, right? So, and those steps are not linear. There are elements that are linear, but manufacturing operations are never purely linear, especially when we look at the ancillary steps on the outside of the manufacturing operations. They are not predefined. They are modeled on variable conditions that coalesce many events into one outcome, which is producing goods, the formulation of which are pre-modeled but not always predictable. All MES solutions are built the same way. I cannot stress this enough. Every MES solution is built exactly the same way. They have a master data model definition in the background. You create instances. You have event tracking, transaction storage. You have post-processing. You have visualization. You got reporting. That's every MES system, no matter what function you're using. By the way, that's lots of software too. You could obviously say that's what software does. So in order for an off-the-shelf solution to deliver without asking clients to fit their round peg into the platform's square hole, the solution must be an event-driven ORM that starts with object and model creation. And that doesn't exist in the market. Why? Because MES isn't a set of capabilities. It's a quilt made up of a client's specific needs. The ORM vendor can't predict the capabilities for every client. That's the technical reasons all MES are built, with a caveat here. You know, Sean and I agree in that statement. I mean, in fact, we both agree that everything starts with raw data being modeled for ingestion into enter in functional capability, right? Yeah. At the end of the day, you would agree that you and I both agree in those elements, okay? Yeah. Let me clarify here. You can buy off-the-shelf MES and then still achieve what it is I'm talking about. What I'm arguing is if you buy off the shelf, you're not just buying it off the shelf, you are extending. And in most cases, you're getting only about 40%, in my opinion, whenever we do it, you're getting 40% of what you need off the shelf. Yeah. But in most cases, that for the price you're paying for that 40% ends up costing you much longer in the long run because you have to fit the round peg into the square hole in order to get that 40%. That is, you have to meet that platform's structural data model, the way it structures events, the way it plans to ingest. I will say this, and I will give Sean credit here, of all the off-the-shelf solutions outside of Tulip, plant applications from GE is the most raw in its ingestion format. That is, it doesn't require a lot of formatting of data to be consumed into the platform in order to be stored as events. And as opposed to, say, if you look at modules you buy for Ignition, you have to highly format that data before you can store it in an MES data store.
And that makes it pretty common with a lot of others. And I would argue that probably where leverage can be found is if that MES data model is reasonably abstract. And again, I think specification definition is the other area where a lot of MESs fall down because they try too hard to have an explicit, fully encapsulated quality event or failure event. They don't necessarily think in terms of, hang on, I just want to measure something. I want to define what's worth measuring, abstract that away from the way I measure it so that I can choose. Here it's from a historian variable. Here it's coming direct from a SCADA. Here it's coming from an MQTT feed. Here it's a human entering it manually via an iPad. And then I encapsulate, and if I've got a good product, there's already pre-built things that say, because of this event here, there's an implication for fitness for intended purpose, quarantine the product. Because of this event here, there's an implication for an unplanned downtime that will last for a while. You might want to create an alert that goes to this user identity. Yep. The more abstract under the bonnet the actual event models are and the spec models, the closer you get to my view, which is you should be able to get 60 to 70% leverage from a package. And in fact, if Mike Graisley probably isn't on this call, the last I checked, he was tasting bourbon in Kentucky. If he was on this, he would laugh because when we used to go together to our customers, they'd say, you need to help us pick the best MES. And we'd say, here's 5, each of which is no better than a 70% fit. What trade-offs are you willing to make? Is it because you've got a strong IT group? You might like the one that actually requires more bending and shaping at a code level in the UX or other areas. Oh, you've got a weak IT group but a strong engineering team. You might be better served by the one where you need to do more perfection of the data coming from the OT layer. But there was never one that we ever said, this one's 100% perfect. We always looked at our customers' goals in their organization and said, partly because of who you are, partly because of where you're headed, this is the rightest one for you.
Okay. So Sean, I will, for those of you, if you want to reach out to Sean, you can find him on LinkedIn, Sean Robinson, put in Novatech. He'll come up. If you're connected to me, he's going to come up as the first option. Sean, I really appreciate you coming on. Man, dude, I take this for what you will. If you think the way you do, you really belong in the Ignition frameworks. I know that Novatech's got the Emerson relationship, so I don't want to knock that too much. But I really think you guys could do some pretty crazy stuff with like pure open IoT platforms, even Tulip actually. So, but I really super appreciate you coming on the podcast.
From my view, all I will say is we've got more stuff up our sleeve that lets us play in those areas with the vendors that we have, including the one with the big round meatball. From you, I will take that as a compliment. Awesome. I will say that I know that I was a little rude in the way that I got us into this conversation. As much as anything, I'm grateful for the fact that you guys showed some tolerance and said, hey, if he wants a fight, let's have one. But then
you came on, man. As long as you're willing to come on, I got no problem with somebody taking shots.
But I will say the cost of building is so cheap. Like you can build an entity, like define your plant, build the entity relationship diagram. You should probably already be doing that anyways, you know, like, and then just build out capabilities.
Like I said, it depends on who your organization is and what the actual long-term cost is. I studied accounting. I did that so I could justify what I do to CFOs. Trust me, there's reasons I believe the balance is, in many cases, buy. I will accept build, because like that comes to my form of who are you as a customer? Your skills, your philosophies, where are you headed? Depending on that, there are definitely cases where I'd say not fill and integrate. If someone has big holes, you shouldn't be able to beat buy. It should give you too much leverage.
Let me finalize with this piece, and this is a really important point I was going to bring up earlier, and I just didn't, which is this. I've always thought that it's very important that the structure of your business and the events of your business are decoupled from the solutions you buy for your business. So if I create a namespace called OEE, and OEE has all of the parameters, all the input parameters I need to calculate OEE, all of the standards that I need to define, like standard rate, scheduled rate, whatever, and then the output parameters where I can write back my availability, quality, performance, and OEE, I should be able to decouple my solution from that model. So I should be able to say, let's say I started with Traxxas, I should be able to decouple Traxxas from the structure and the events of my business, plug a different OEE engine in, and be able to consume the same events and publish back to the exact same. I've always firmly believed that. I have not, now, to be fair to GE Plant Apps, I have not attempted that yet. I do know it's possible because of the connectors that are supported. So, but I would like to try it. So it's a huge, at the end of the day, I've done a deep dive on Plant Apps many times. At the end of the day, it's a TCO. I'd love to have a longer conversation with you on total cost of ownership so that I can make that case at the end of the day. That's the, but go ahead.
I want to point out though, that you do sell an MES product. You have a MES 4.0, but you still teach people how to build their own MES.
In fact, we teach them how to build it from that product.
Yeah.
That's literally what we, so
you're obviously you're in the favor of build over buy.
Josh, real quick, any questions that we need to answer? I know we've got Sean 20 minutes over, but any questions that we should answer or call it a day?
This was good.
It was a good one. Sean, I really appreciate you coming on, man.
No, hey, appreciate the invitation. Next time, let's find something we can also agree violently on a totally different topic.
I totally agree. We definitely want to have you back. I think you're a great guest. So, all right, Sean, appreciate you. Everybody, thank you for watching. Like, subscribe, comment down below, and we will see you guys.